Now, we've covered a number of libraries in the Hadoop ecosystem, and I want to kind of put a reality check in. Why the fuss? What it really comes down to is Hive isn't fast enough. People want to use a SQL-style language, and they want fast results against a huge amount of data. In essence, they want a bigger, faster, cheaper relational database. They don't really care that it's using Hadoop storage and MapReduce and all these other low-level architectural differences. The business users, the people who are funding the big data projects, the people who are getting the actual value, really just want bigger, faster, cheaper, better databases that work like relational databases. So is that possible? Again, one of the things I find over and over in big data projects is I need to be very clear about whichever library that I use, whether it's Hive or Impala or some other vendor's library, if I'm using a subset of ANSI SQL. The majority of the people working with data in the enterprise are very, very knowledgeable about ANSI SQL, and they have an expectation that any database system that they work with will work in a way that is compliant with ANSI SQL, and that just isn't the case with Hadoop. So why do they use Hadoop? Because the volumes of data are becoming such that it's no longer cost effective to put all that data in expensive proprietary relational systems like Oracle or SQL Server. They want to use the cheap distributed storage of HDFS. Or you might remember from earlier movies in this course, you can actually implement the MapReduce algorithm on something as cheap as S3 file storage or Windows Azure Blob storage, which can be phenomenally cheaper than putting data in a relational database. Also, the data may not be of value because you're collecting behavioral data and you might just be pulling aggregates and discarding the rest of it or not looking at it to warrant it being put in your relational database. Another consideration around all these libraries is MapReduce will always be the core of Hadoop. Another consideration around all these libraries is that although MapReduce is the core of the Hadoop ecosystem, as the world of big data problems grows, MapReduce becomes a small subset of the type of computation that is required to produce effective business results, whether it's something like a machine learning library or something or scenario like complex event processing. These are far beyond what the designers of MapReduce envisioned when they first released their white paper 10 years ago. Real-world data tasks encompass many more scenarios than MapReduce, so there's a need for additional libraries for almost every production Hadoop deployment that I've worked with over the past few years. Even though there's a need for libraries, using libraries for library's sake is not a smart strategy. Hopefully, if nothing else you've gained from listening to this course, libraries add complexity. You want to add them only when business needs justify, and when that particular library and its associated tooling is mature and can perform at the levels that you need for the volumes of data that you have and the resources in terms of hardware and such. In addition, enterprises often test on open source libraries, but they find that either they're too difficult to use, not mature enough, so they will subsequently often buy products that reflect a superset of those libraries. We talked about that in terms of the event streaming, in terms of the log ingestion, and some of the other business scenarios. So don't rule out or fail to budget for purchasing products that are more performant and easier to use than these free libraries. There's a myth around the implementation of Hadoop that it's all free and open source and it just magically works. There are associated costs to Hadoop. Big data solutions are not free, and companies that plan and understand are going to have a much greater success with big data Hadoop solutions. It's very interesting to me that although the Hadoop ecosystem is hot and growing, the technology itself is over 10 years old. And Google, the people who created the technology that Hadoop is based on, has actually augmented their own implementation of Hadoop with next-generation products. These products are really interesting. One of those products in particular, they've made commercially available. And I want to show it to you because I think it's really interesting in understanding Hadoop libraries and limits and performance and possibilities for the future. The product is called BigQuery, and it's technically query as a service. The goal with BigQuery is to process petabytes of data in seconds with ANSI-compliant SQL. Sounds like what the majority of the Hadoop customers want, doesn't it? BigQuery is so far beyond the Hadoop ecosystem, it's actually difficult for people to understand what it does. It's sort of like the Google search engine. It's so simple and elegant. There are some limitations. You do have to upload your data to Google, and for some businesses, that's not an acceptable scenario. Also, it is a new business paradigm to pay for queries on the cloud as a service. It's very difficult for businesses to understand how to budget for that. I'm not advocating particularly for using BigQuery, although I do personally use it, and I'm going to show it to you here in a minute just to be inclusive. Why I've chosen to include BigQuery in a course about Hadoop is because it in some way reflects the possibility of Hadoop's future. Google has open sourced their implementation. It's called Google Dremel, and there is an incubating Apache project called Apache Drill, which is implementing some of the technology behind BigQuery. So I'm going to actually show you what it looks like because it's easier to actually look at the implementation than to describe it. Here I am in the Google Cloud. If you've not used the Google Cloud before, this is the Google's version of the Amazon Cloud, if you will, or the Azure Cloud. So it's cloud-based services that you pay for. So they have a free trial, and if you're new to the Google Cloud, you can try it out that way. So I'm going to go to my console, and I'm going to go to my API project. And inside of here, I'm going to go to Big Data and BigQuery. And I have two things that I can do in this interface. And this is a web-based interface so that you can try things out. BigQuery has an API, which is most commonly used in business scenarios that you send and receive data and results back and forth, and you pay by the query. So you have a job history, and the jobs are copy and load jobs where you add data to the Google Cloud, and this will be stored in the Google file system. Similar to Amazon S3 file storage, Google has Google Cloud file storage where you would place your data that would then be queried. There's no need to use any sort of HDFS with BigQuery. And then you have your query history. If you wanted to compose a query, you just click right here, and then you just type your query in. Now you have a metadata browser for your tables. And you can see, for example, I've got public data down here, and I have GitHub information down here. And this shows me the schema. And then I can look at the details. And this is information about commits from GitHub. And I can query the table if I want to. I'm going to do a select star just to get everything. And you can see in 16 seconds, I processed 3 gigabytes of data. So what Google has done is they've made this stunningly simple. You just upload your data, and then you run a basically ANSI SQL query. It's about 80 to 90% ANSI SQL compliant. It's a higher level of compliance than HQL. And then you get your results. Now you have some options around here where you can save a little bit of money. Notice they have interactive and batch. So you can see this comes from the Hadoop history. And then you have caching. And you also have some information about appending or overwriting because this is not HDFS. So you can overwrite if you need to. You can download the results as CSV. And just to go into my query history so you can take a look at this. So now I'm going to show a query that's a bit more complex. Let me just go ahead and load this query by clicking Edit. And you can see I've got a select top and a count. And I'm going to be selecting from Wikipedia. And let me go ahead and run that. And you can see after 6 seconds, I processed 9 gigabytes. So it'll be interesting to see as the Hadoop ecosystem evolves how the implementation of Apache Drill affects the Hadoop libraries. It's something to watch, and that's why I included it in this presentation.